Hi everyone, so good morning and we are live now. Uh, okay, and in the discussion of random variable, like probability and statistics, we have done many sessions on random variable and we are very close to wind up this discrete random variable paradigm. Okay, and we will be switching to continuous random variable and related distributions and density, uh, various types of densities, and we have to particularly discuss the Gaussian random variable and the Gaussian density function, right? For GATE 2025, for data science and AI, uh, you know, random variable plays an important role, particularly the continuous random variable. Okay, so you have to watch each and every sessions very carefully, and after finishing the session, the book which I have given to you in the group, right? That book you have to refer, okay, and for the problem solving, okay, and then you have to switch to some PYQs, some previous questions, okay. So for electronics and communication and other branch of engineering, they have got many questions in probability theory and random variable say, and but as far as the data science and AI is concerned, only 1 year paper is there, right? So it's fine, you can practice. Okay. So without further ado, we shall directly move to our favorite board. Okay. So as you can see, this is going to be our lecture number 15. Fine. Lecture number 15 on this random variable, and today we are going to talk about conditioning a random variable. Okay, conditioning a random variable. So if we are going to condition the random variable, I think everybody knows what is conditional probability. Okay, conditional probability क्या होता है, and how do we define conditional probability and all. You need to have the joint probability, right? Okay, and you need to also have the ordinary unconditional probability. ठीक है. So if we are going to condition the random variable, then what is going to happen? See, the concept is same. Whatever you have learned in conditional probability paradigm, okay, the same concept you have to apply here also. Little bit of change in terms of notation. That's it. ठीक है, और कुछ भी चेंज नहीं होने वाला है, तो आपको ये समझना पड़ेगा. ठीक है. So let's begin here. So in this session, what are the things that I'm gonna talk? So we'll talk about conditional PMF. Okay, after conditioning random variable, understand, and then we will talk about independence of the random variable also in this session. Independence of random variable. Okay, so we'll talk about conditional independence as well, right? Conditional independence, you can say. Okay, conditional independence. Fine, 1 minute, I think. Yeah, we'll talk about conditional independence as well. Fine. So, and we'll talk about conditional expectation. We'll talk about conditional, total expectation theorem, because, total expectation theorem depends upon the conditional expectation. Then we'll talk about independence of the random variable, many more things, right? So let me show you all these topics, okay, in detail. So these are the topics that I'm going to talk. Okay. These are the topics that I'm going to talk here. Conditional PMF, already we discussed conditional PMF, but how, in the last session we have conditions on the event, right? But now we are going to condition on another random variable. ठीक है, we will be having unconditional PMF. हमारे पास एक unconditional PMF रहेगा, और हमें condition किसके ऊपर करना है? We have to condition on the random variable itself, right? And then we have to compute conditional expectation, total expectation theorem. I think everybody knows total expectation theorem. Independence of the random variable. So if you know the independence concept, back then we have discussed in probability, okay, like independence of two events and pairwise independence, collection of independence, collection of various events, okay, if we have got, so we can find the independence. And we will talk about expectation property, variance property, and variance of binomial random variable. All these things we are going to discuss in this session. Okay, chalo. So let us start here. So you know that as we have seen the conditional PMF when we are going to condition on the event, right? So what is that conditional PMF that we have seen? Conditional PMF. Conditional PMF we defined was P. This is PMF for the random variable X condition on A. Okay, that is X is equal to. Okay, this is nothing but a probability only, right? So this is nothing but probability of, you know, capital X equal to small x given that A. So this was the conditional PMF when we were conditioning on the event. Okay, and here the A is the event, you can say. A is nothing but the event, right? You can say A is the event, which is nothing but capital by is another random variable which takes the value small by. Okay. Okay. So what you can do now is you can just forget about this event now, right? Forget about this event. You can also write here A. So what you can now do is you can replace this A by capital by. Okay. So now my conditional PMF is gonna be X given another random variable by. We are conditioning on the another random variable by. Okay. X given by is equal to. Okay. I think this is clear. Is going to be equal to the probability of, you know, X equal to small x given that capital by equal to small by. Okay. This is by definition. Okay. This is the definition when we condition on another random variable by. Okay. So we are conditioning on another random variable by. Okay. So from the definition, what is going to be this? From definition, you can say that it is going to be X equal to small x and by equal to small by upon probability of by equal to small by. Okay. I think everybody knows this. Okay, from the definition of conditional probability, right? The common and means here intersection. You can also put intersection in and. Okay. Intersection. So I think this definition is clear, and we are talking about discrete random variable, guys. So there should not be any issue, right? So how to write, how to express this? This we have expressed in terms of probabilities, sir. But suppose we have got the joint PMF. We have got the joint PMF, and we have to find. Okay, so what is the algorithm here, guys? Algorithm here is suppose we have been given joint PMF. Okay, and to determine conditional PMF. Okay, what are the things that we need? So if we have been given a joint PMF, remember that joint PMF agar given hai, okay. So how can you find conditional PMF? Conditional PMF is gonna be X given by small x, okay, is equal to the joint PMF. You have to take the joint PMF here, that is X comma by, okay, that is X comma by upon, this is joint PMF, remember, okay. This is how we denote the joint PMF, X comma by, or you can also write, X comma by, okay. And what we have to divide here is we have to divide by the marginal probability for the random variable by. Okay. So this is very important to keep in mind. Okay. Now the question is only joint PMF is given. देखो question में आपको केवल joint PMF दिया रहेगा. In case of discrete random variable, in case of continuous random variable, they will give you joint PDF. मैं आपको फिर से बताऊंगा. In case of continuous random variable, they will mention joint PDF. Okay, probability density function. So if you want to find conditional PDF or conditional PMF, now the question is why do we want to find conditional PMF? आपके माइंड में पक्का ये क्वेश्चन आएगा कि why do we want to find conditional PMF, सर? देखो conditional PMF इसलिए फाइंड करना है. The reason is very easy reason. क्या रीजन है? You have to find the conditional expectation at the end of the day. So if you want to find conditional expectation, you need conditional PMF. Yeah, conditional expectation in case of continuous random variables, you need conditional PDF. Or this year in GATE examination, GATE 2024 in data science and AI paper, there was a question. And we can also expect questions in electronics and communication paper as well. Okay. Largely. Okay. From random variable. So this is important, right? So please remember these notations, guys. Okay. So how to find this marginal PMF, right? So this is marginal. Let me mention all these things because you should be able to read it. Okay. ये क्या है आपका marginal है, marginal PMF for random variable by, ये क्या है सर? This is joint PMFs for random variable x and y. Okay, x and y, and this is nothing but your conditional PMF. So you see there are three types of PMFs, and there were three types of probability as well. Okay, fine. So now question is how to find marginal PMF, right? So you should know that कैसे PMF find करते हैं, marginal PMF. I have told you the algorithm. You have to, suppose joint PMF is given. Suppose joint PMF is given, right? And if you want to find, to find PMF for the random variable by, then what you will do, you will sum over x, right? You will sum over x your joint PMF. So this will give you the marginal. So from joint we get marginal. Remember these points, guys. Okay, मैं बार बार बोल रहा हूं, ये बहुत important है. From joint you can get the marginal. Okay, and this is the requirement. Okay, according to whatever question will be given, according to the requirement of the question you have to compute it, right? There is no other way, right? And if you want to find the joint PMF, marginal PMF for the random variable x, then you have to run the summation over by, and it will be given, right? Remember, it is going to be given, right? This guy will be given, ये दिया रहेगा. Okay, this guy is gonna be given. Okay, remember this. So I think this is clear for all, yeah. So to determine, ऐसे आपको orally याद रखना है. To determine marginal PMF और marginal PDF. PDF किस केस में रहेगा? In case of continuous random variable. Okay. So you have to, in case of continuous random variable, the role is gonna be changed. Summation and integration role is gonna be interchanged. That's it. Okay. In case of continuous random variable, you have to use, in place of summation, all the summation has to be replaced by integration, sir. अब देखो ये मत बोलना कि सर इंटीग्रेशन नहीं आता है. I will teach integration as well. Integration is okay. X given by is nothing but what, guys? The joint PMF upon, okay, okay, 1 minute. Yes, sorry for interruption, right? So this is conditional PMF, and you will be given joint PMF, right? And you can find the marginal PMF from the joint PMF and compute it, right? I hope this makes sense. And here you have to make sure that since this marginal PMF is in the denominator for the random variable by, so it should be defined for, it is defined for what? Defined for by, okay, defined for by such that your marginal PMF for the random variable by must be greater than 0. ये important condition है. It should never be 0. Okay, should never be 0. Okay, it should be always positive. And you know that if you run the summation over conditional PMF, right? Okay, that is going to be 1 only, sir. And if you're going to run over x, okay, if you're going to run over x, okay, if you're going to run over x, it is going to be 1. ये तो बहुत ही बेसिक चीज है, ठीक है. So suppose you have got conditional PMF and you have got marginal PMF, so you can find the joint PMF. That is also one very easy thing that you can remember, right? So one more thing that you have to remember is this. Joint PMF. Now you don't have to mug up anything, since you know the probability, right? You can find out. Okay, you can relate this with the probability of probability A intersection B is gonna be probability of B times the conditional probability, right? तो ये क्या है आपका? This is nothing but your joint PMF. This is marginal and this is conditional. So based on the requirements, you have to just compute it. Okay. So after finishing random variable, probability and calculus, you should be able to, solve all the questions and PYQ of all the gate. Yes. So there is some interruption, okay, in the setting, but it's fine. Okay. So I think this is clear for all, and you guys can understand that. Okay, what is this? What is the meaning of conditioning a random variable and everything, right? Okay, and you can solve the question if okay. Now if I talk about suppose we are going to talk about conditioning on more than 2 random variable, right? Till now we are conditioning over 1 random variable, right? But it might happen that more than 2 random variable भी हो सकता है ना, more than 2 events भी तो होता है, ठीक है. ओके, देखो कंडीशनल पीएमएफ, 1 मिनट, conditional PMF, okay, conditional PMF involving more than 2 random variables, okay, more than 2 random variables, okay, more than 2 random variables, conditional PMF involving more than 2 random variables, fine. So it is very easy, and it is, you can say, kind of self-explanatory notations. Okay, so you can say that probability mass function for the random variable x conditioned on by and z. ये क्या हो जाएगा सर? You can take the random variable x takes the value small x and then by comma g is equal to what? Very simple, right? It is going to be what, guys? It will be nothing but the probability, right? It is going to be the probability x equal to small x and by equal to small by, g equal to small g. Okay. Now, how to define conditional PMF, right? Conditional PMF is defined based on what? Conditional PMF is defined based on the joint PMFs, right? So you can write joint PMF here. तो ज्वाइंट पीएमएफ क्या हो जाएगा बताओ? वेरी सिंपल, राइट? सो इन टर्म्स ऑफ प्रोबेबिलिटी यू आर राइटिंग सो x इक्वल टू स्मॉल x, y इक्वल टू स्मॉल y एंड z इक्वल टू स्मॉल g अपॉन what? Upon whatever is given. You can say y equal to small y, okay, and comma z equal to small g. So in terms of PMF you can now denote, okay, so in terms of PMF you can write this as x comma y comma g, x by g. This is joint PMF, okay, for the random variable x by g upon, and this is also going to be joint only, right? So this is very simple. It is very very simple to understand. आपको ये याद नहीं करना है. How I am writing, you have to follow it. That's it. So if you have understood the conditional probabilities, okay, that tree diagram and all, you can also write this using tree diagram. ठीक है, तो पहले आप start करो probability से, write PMF in terms of probability, then put in terms of notations, right? Actual notations. Okay, so you will not find any sort of difficulty. Okay, so let us talk about multiplication rule. If there are three events, if there are three events, so what is going to be the multiplication rule? Okay, so that we can talk about this. देखो, this is joint PMF, right? And there are three random variable, guys. In the GATE examination, in GATE 2024, there were 5 random variables. आपके एग्जाम में 5 random variable आया था सर. How to, how this will be given? Joint PMF, there are many, you can say there are 3 random variables. Okay, there are 3 random variables. In your GATE 2024, there was 5 random variable, okay, in the paper. Fine. So, first of all, let us recall the multiplication rule. Let us recall, we call it multiplication rule, or we call it chain rule. हम इसको चेन रूल भी बोलते हैं. तो मान लो तुमसे पूछा जाता है कि व्हाट इज द प्रोबेबिलिटी ऑफ ए इंटरसेक्शन बी इंटरसेक्शन सी, or you can also write this as probability A comma B comma C. Notation is same. What is going to be this? So how to write this? Okay, so you can recall the tree diagram. So tree diagram में क्या रहेगा? Suppose one of the event A has happened. Okay, just focus on the only kind of success, right? Not on the complement of the event, right? Just actual event you have to focus. Next event is going to be B. Next event is going to be C, right? So what is this, guys? This is probability of A, this is probability of B given A, and this is nothing but probability of C given what? These two events has already happened now, so you can say A comma B, right? Joint probabilities. Okay, I mean these two event has already happened. Okay, so what is going to be the probability of A intersection B intersection C, which is nothing but the product of all these probabilities. इनका सबका प्रोडक्ट देखो, इनका सबका प्रोडक्ट क्या हो जाएगा? प्रोबेबिलिटी ऑफ ए टाइम्स द प्रोबेबिलिटी ऑफ बी गिवन ए, राइट, टाइम्स द प्रोबेबिलिटी ऑफ सी ए इंटरसेक्शन बी. यू कैन राइट लाइक दिस, ए कॉमा बी ए इंटरसेक्शन बी, वॉट एवर, दैट इज द मैटर ऑफ नोटेशन. ठीक है, तो ये देखो मैंने कितना इजी तरीके से लिख दिया. ओके, हाउ सिंपली वी हैव रिटन दिस. यस, can you write like this without any extra pressure in your mind? Yes, you can write. Okay, मान लो वहां पर 4 events हैं. See, I'm talking about in terms of event right now. Okay, just to make you feel comfortable, you can replace this event using the random variable. You know that how to represent events using random variable, using inequalities, equalities. Okay, ठीक है, आपको पता है कैसे इवेंट्स को हम लोग रिप्रेजेंट करते हैं इन रैंडम वेरिएबल पैराडाइम. ओके, प्लीज वॉच माय लेक्चर्स, ओके, केयरफुली. सो नाउ वी कैन राइट डायरेक्टली. सो दिस इज ए इंटरसेक्शन बी इंटरसेक्शन सी. नाउ इट इज स्टार्टिंग फ्रॉम द ordinary probability, that is unconditional probability of A. Now the second event is coming, that is B, or A has already happened, so we can say that probability of B given A, then C has to happen, so probability of C given that A intersection B. Now you can write anything, right? We can write, okay, let me write. Suppose there are 4 events, A B C D. Okay, what is this joint probabilities, guys? So probability of A times the probability of B given A times the probability of C given A intersection B. Now the probability of D given A intersection B intersection C. Going on, right? So see, there are 4 events, so 4 terms. Okay, I think this is clear. Fine. Let's say A and B are independent. अगर मान लो A and B are independent event, then what will be happen? If A and B are independent, means probability of B given A is nothing but probability of B only, sir. If A and B are independent, see here, if A and B are independent, then we can say that probability of B given A is probability of B, right? So this expression will become what? This will become what? यहाँ पर आप लिख सकते हो probability A times the probability of B, and this is probability C given A intersection B, and probability D given A intersection B intersection C. Okay, but this is only possible when A and B are independent. और आपको ये भी पता है कि if A and B are independent events, it does not mean that they might be conditionally independent. Okay, that is also very important to remember, because from the very basics of probability, they can be conditionally independent, but they have to follow some conditions, okay, of conditional independence. ठीक है, तो ये सब चीजें आपको पता होना चाहिए, राइट? Okay, so what we can do now is, let us forget all these things, okay, and let me keep this only, okay. Baki discussion is big, right? So you can think about it. So this is nothing but what I wanted to recall using chain rule or multiplication rule. Now what we can do here is we can define the events in terms of random variable. So A is nothing but the one event, that is capital X equal to small x. Since we are talking about discrete random variables, so equality we can take. B is going to be by equal to small by, and G is going to be, G equal to, sorry, C. C is nothing but small g. Okay. Now, if we are replacing the events with the help of random variable, so we have to discuss about PMFs, right? Okay. So P ये क्या हो जाएगा? A x by g, right? So we can write this as joint PMF x comma by comma g, x comma by comma g, which will be equal to, this is nothing but what? The probability mass function for the random variable x, okay, and this is nothing but conditional PMF, the probability mass function, probability mass function by given x, okay, probability mass function by given x, okay. Why by first? Because probability of B given A, right? So by must come first, and then this is nothing but what? This is going to be your next PMF g given x comma by, capital X comma by. Okay. Whatever subscript you're writing, that has to be written in terms of capital X, okay, capital letters. So this is the story here, you see. Okay, so if you are able to recall the chain rule, okay, and if you are able to write the joint probabilities, so with the same analogy, you can also write this. You see, in place of this, we have to replace this into, okay, conditional probability, conditional PMF, and there are two, we are conditioning on two events. Okay, so we have got two random variable. Yes. तो ये आपको समझ में आ गया होगा, ठीक है? तो ये इंपॉर्टेंट पॉइंट आप याद रखना, ठीक है? And we will also discuss, you can say, the Bayesian network, right? Bayesian network to determine the conditional independence and all. Okay, when we will solve the problem. Okay, so because the problem of conditional independence can be done using Bayesian network very quickly, right? Okay, somebody is from computer science background, they might have studied about DAG, okay, directed acyclic graph, DAG, okay. So using DAG, because the Bayesian network is motivated by DAG, okay. But for electronics people, you don't have to worry about anything. Very simple question will be asked, right? But CS and data science in AI, I'm telling, okay. Now let us talk about conditional expectation, sir. ये आपका खत्म हो जाता है conditional, your conditional PMFs. So now we will talk about conditional expectation. I think you know that conditional expectation, because already we have talked about conditional expectation when we were conditioning. Yes. So some interruption happened, right? So it's fine because of some internet glitch. I am not sure, right? So yeah. So let me switch to our favorite board, right? Yeah. So what we're talking about, guys, now is the conditional expectation, right? So conditional expectation, so this is nothing but unconditional expectation from the very basic definition. In place of A, what we can do here is we can consider the event by equal to capital by, small by, okay? And this is very important conditional expectation, okay? In the gate 2020, 4 question was there, right? In gate okay. So first of all, let us condition the run on the event, okay? So we can say that uh, x, given that A is nothing but the over x, okay? Here we have to use the conditional PMF, okay? This was the idea, right? Sorry, this was the idea. You can say x only. Okay, this was the idea here. But as if you're going to take by equal to small by as the event A, what you have to do here is you have to write in place of A the by. Okay, so your conditional expectation will become, because we are conditioning over by, right? We are conditioning over by. Understand? So if we are conditioning over by, then you can say that this will be equal to summation over x, right? You have to remember this point. Summation over x only. Okay, the summation has to be run over x. Okay, whatever is there, expectation of x given by, so you have to run summation over x only, provided your conditional PMF will become x given by small x small by. It is one of the very important definition, guys. So in case of, this is for discrete random variable, sir, but in case of summation, in case of continuous, मान लो जैसे ये discrete है, discrete random variable and continuous random variable, right? Continuous. So here we are using summation, here we have to use integration, that's it. बस इतना ही चेंज रहेगा. And here we are talking about PMF, there we will talk about PDF. Okay. Understand? Fine. So let's move ahead and wind up this. Okay. So this is nothing but your conditional expectation. Please remember this. आप बार बार इसको लिखोगे ना फॉर्मूले को, expectation of x given by is nothing but, in the exam they will ask expectation of x given by. Okay. So you need to find conditional PMF, but how to find conditional PMF? You must be given joint PMF, right? So ये हो जाएगा x, and here you have to recall conditional PMF. Okay. And I can show you the question as well. I can show you the question, right? But that question we will not solve at this juncture, right? Okay, later we will solve. And you can also change the expected value rule. Expected value rule. You can recall the expected value rule. For the unconditional PMF, the expected value rule says that what? If there is a function of random variable is given, right? If there is a function of random variable, you can say by equal to g of x. Okay. What is expectation of by? Which is nothing but expectation of g of x. And you have to run the summation over x only. G of x. But you don't have to find the PMF for the random variable by. You have to just write the unconditional PMF of the random variable x only. This is the expected value rule for unconditional. Okay. But if you condition on it, suppose x given a, okay, x given a, sorry, your random variable is nothing but a function of your random variable becomes the function of a random variable, that is g of x given a. So in this case, what will be the definition? Definition is going to be same only, right? Here again you will write x Now your PMF is going to be the conditional PMF and we are conditioning over an event. Yeah. So आपको style पकड़ना है how Dheeraj sir is writing now, but in place of A, what we can do here is we can write this y equal to small y. We are conditioning over a random variable. Conditioning on a random variable. So this, your expected value rule becomes g of x given that by, okay, expected value rule becomes, okay, given that by, okay, ठीक है, fine. So what we can do here is this is nothing but a small by also you can write, okay. So this will become summation. Now here also x will be there, no change, but your conditional PMF is changing, right? Only conditional PMF will change, that is x given by and x. So many students do not understand that, okay. ये देखो यहाँ पर x होगा, it depends upon the function of random variable x and this summation is also over x, okay. So all these formulas, please remember that. And you can also recall total probability theorem as well as the total expectation theorem. Okay. Okay, in terms of when you are conditioning over the event. Okay, that is very simple to remember. Okay. I'm just going to recall it so that you guys can understand. Total probability and total expectation theorem. So I'm not going to prove again, you guys can prove it, okay, because that is simple, okay. So first of all, what you have to do, you have to partition the sample space. So partitioning the sample space, the very first thing is partitioning the sample space, okay, sample space, right? Like, you know, A1, A2 and dot 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 AN, okay. Sample space you have partition. Now these A1 and A2 are nothing but what? The events only, right? Okay, disjoint events. So we can define the random variable, you know, like by is nothing but by 1, by 2 and so on by n, okay, where this AI is nothing but a particular partitioned, okay, event is going to be by equal to small by I, right? Okay, for each partition, okay, we are going to assign random variables, right? So हम लोग कुछ नहीं कर रहे हैं, we are not doing anything new here, right? Already we know these things, okay. So we can write the, you know, total total PMF. Total PMF is nothing but, okay, this is the total PMF and total PMF is nothing but the probability times, this is the probability of A1 times the conditional PMF, okay, this is the conditional PMF, right, plus probability of AN times, I think in the previous session we have discussed this, AN. So in place of this we have to write by 1, right, that's it. So this is probability of A1 times, now A1 is nothing but what? By 1 equal to by 1, right? Okay. So what we have to do here is we have to write like this, you know, this will be equal to x given by 1 now plus the probability of A and the probability mass function, you know, conditional probability mass function, this is by n, okay, by n, okay. So we can write this as in compact form, sum over by, okay, we have to sum over by, right? And here this is nothing but your random variable by. In place of a1 here you can write by, no problem. I mean, you can write this as okay, in place of a1 we can replace a1 by 1. So by 1 equal to by 1. Okay. In place of this we can write this as by n equal to by n, right? These are the events. Now this is the you can say that marginal PMF for the random variable by, okay, times the conditional x given by small x by. This is the total PMF. Okay? Total PMF. Okay? And how to write the, how to find the total expectation, that also total expectation is gonna be the expectation of x is going to be the probability of a1 times the conditional expectation plus and so on, plus probability of a n. Suppose there are n number of partition, conditional expectation given that a n, right? So you can replace this a1 and everything, right? So you can write this as expectation is nothing but sum over by the conditional expectation. Okay. So what we can do here is we can write this as the marginal PMF. Okay, marginal PMF of and here this will be the conditional expectation, right? So just write conditional expectation, that's it. Okay, conditional expectation x capital by equal to small by. ये देखो, ये सब फॉर्मूले हैं जो आपको समझना पड़ेगा. Okay, whatever is given, you notice here corresponding PMF you must know, and you have to sum over by. This is one of the important fact of total expectation theorem. Okay. Now we will talk about independence, sir. Independence of the random variable. Okay. Independence of the random variable. We will talk about independence of the random variable, and then we will talk about and independence का application क्या है? What is the application of independence, right? That is also we have to see. Okay, and from that also you have got question in GATE exams, right? So please remember that. And how does independence affect variance? Okay, that is also we have to understand. Like suppose two random variables are independent to each other. So what will be the effect of independence on the variance, expectation, okay, and so on and so forth. Okay. Okay, and where do we use this concept? Okay, understand. So let us move ahead and talk about these new concepts, that is nothing but independence. Okay, so you can recall independence of the two events. Okay, because already we have discussed that. देखो, you don't have to take anything new here, right? आपको पहले मैं बता चुका हूँ, ठीक है? What is the independence of the you can say if there are two events, right? So how can we prove independence? ठीक है, मैंने आपको different types of independence बताया था. One was the pairwise independence, ठीक है? One was the independence of the collection of events, right? So if there are collection of events, so we can find the independence collectively. Also we can prove pairwise independence by picking randomly two events and conclude they are independence, right? So ये सारी चीजें आपको फील करना पड़ेगा. अब आपको ऐसा नहीं लगता oh my god, it's a very difficult situation, right? You have to, okay, and really they will be giving you a great impact in your life. मैं आपको बता देता हूं कि लीनियर अलजेब्रा, प्रोबेबिलिटी एंड कैलकुलस अगर आपको आने लगा तो आपकी लाइफ बहुत अच्छी हो जाएगी. लेट मी गिव यू काइंड ऑफ गारंटी, ठीक है? So let us talk about independent of the random variable x. Independence of random variables. Okay, so if two random variables are independent to each other, right? So initially what we can recall here is suppose two events are independent to each other, right? So two events independent. So intuitive definition you can say recall it, that is probability of A given B is nothing but probability of A, or you can say probability of B given A is nothing but probability of B. ये इंट्यूटिव डेफिनेशन मैंने बताया था, intuitive definition, right? Okay, and by definition you can say that by definition if you recall the conditional probability, that is A given B is equal to joint, okay, joint, understand? So from here you can say that the joint probability is gonna be the probability of B times the probability of A intersection B, sorry, A given B. But if A and B are independent events, okay, I have also told you independent event means the occurrence or non-occurrence of one event does not affect the occurrence or non-occurrence of another event. They don't disturb each other, right? Whether they are occurring or non-occurring, right? So A and B. So इसको आप कैसे लिख सकते हो सर? Probability of B times the probability of A. आप इसको ऐसा भी लिख सकते थे, probability of A times the probability. So if they are independent, if A and B are independent, means you can multiply the product, you can multiply two probabilities and that has to be equal to the joint probability. ये probability के terms में है. But if there is a event, you know, if there is a random variable and event, अभी यहाँ पर दो events हैं, if यहाँ पर two events हैं A and B, but now this is the case one, you can see. But now what we will consider here is consider a random variable and an event. एक event ले लेते हैं और random variable ले लेते हैं, right? So you can say that the probability of x equal to small x is the random variable here. This is and an event A. मतलब ये intersection ही है सर. And लिखो, intersection लिखो, both are same. So if they are independent to each other means x equal to small x and the probability of A. This is by definition, right? You can say for all x. If they are independent to each other, you can write by definition, okay? Understood? And intuitively what you can say that if the random variable x and the event A is independent to each other, that will be equal to what? It is going to be the PMF only, sir. PMF of x only, unconditional PMF. ठीक है, ये चीज मैंने आपको ज्योमेट्रिक में भी बताया था, फॉर ऑल एक्स. फ्रॉम द वेरी बेसिक डेफिनेशन वी आर राइटिंग ऑल दिस, ठीक है. एंड सपोज इस ऐसा दिया है PMF ऑफ event A given that a random variable x, capital X, okay. I think this is clear, right? So if we are conditioning over a random variable x, if we are conditioning, remember, if we are conditioning over a random variable x, okay, if we are conditioning over a random variable x, probability of A given capital X equal to small x, that has to be equal to probability of A only for all x if they are independent events. And after all, this is the event only, this is also event, okay. In random variable, how to represent event, that I have told you, okay. So you should not face any sort of difficulty. And if I take case number 3, let's take two events, sorry, two random variable x and y. अगर ये दो random variables हैं, how to prove independence to each other? Okay, so they are, you can say that in terms of probability, if I write, so x equal to small x and capital Y equal to small y, which is going to be equal to product x equal to small x, y equal to small y. Their joint probabilities, in place of A, we have written x equal to x. In place of B, okay, these are the two events. It's, random variable takes some value means that is the event in case of random variable, okay, paradigm. Okay, this is for all small x and y. Okay, if they are independent, right? If they are independent, you can say, देखो ये important है. So they are PMF. They are conditional PMF. X given by small x by is going to be equal to the ordinary PMF, that is marginal PMF of the random variable x. Okay, and suppose it is given by given x, capital X, that will be equal to the marginal PMF, right? Okay, marginal PMF. So its joint, so its joint PMF will become, okay, if x and y are independent. If x and y are independent, so joint PMF, this is nothing but a joint PMF. If x and y are independent, in the question they will mention, or you can also prove it. So you can write their individual product. You can multiply it to marginal, PMF or marginal PDF. Okay. So that will be marginal PMF. Okay. This is only true when x and y are independent. Only true when x and y are independent. Otherwise, it is not true. Okay. तो अगर आप ये पॉइंट याद रखते हो, देन लाइफ इज वेरी सिंपल. ओके, सो इफ देयर आर थ्री रैंडम वेरिएबल, एक्स वाई जी, अगर मान लो थ्री रैंडम, यू कैन एक्सटेंड दिस एक्सटेंशन x by g, three random variables are independent. If they are joint, and in the gate examination most of the time they will give you question where the random variables are independent only, right? So that your life will be very simple. So here you have to multiply the individual PMFs, right? ये देखो इंडिविजुअल मल्टीप्लीकेशन, अगर मान लो 4 हैं, एंड दिस इज फॉर ऑल, यू कैन से फॉर ऑल x, y, g. Okay, understand? So independence, and there is one more concept called conditional independence, sir. Conditional independence. So conditional independence you can recall from your from your conditional probability. Okay, so we'll take examples as well, but not in this session. Okay? We'll take examples. Dekho, where do we use this independence concept, right? So I think we have computed independence, like we have computed expectation of the binomial random variable, right? So there we use independence concept. So independence and the expectation, how they are related? Independence and expectation, how they are related, right? See, when we add, okay, see, when we add two random variable, okay, so what is there when we add two random variable, right? So we follow linearity, right? Expectation of x plus y plus g equal to expectation of x plus expectation of y. But in case of product of two random variable, that is not the always the case. Okay, please remember that. ठीक है, क्योंकि आप जब ऐड करते हो बहुत सारे रैंडम वेरिएबल्स को, यू कैन राइट ऑलवेज द, इफ x by g are independent, so you can just write x expectation of x, expectation of y, expectation of z. In general, you have to remember this. In general, okay, the expectation of the function of random variable x comma y, function of two random variables, this is nothing but a function of two random variables, okay, x and y, okay, is not equal to, okay, is not equal to the function of the product of what, function of the product of expectation of x and expectation of y. एडिशन के केस में फाइन, in case of addition it is correct, okay, whatever function is there like x plus y, so summation is the function over there, so they will be added, right? यहाँ पर फंक्शन समेशन हो जाएगा. देखो मेरा कहने का मतलब है कि सपोज एक्सपेक्टेशन ऑफ x प्लस वाई, so here what is g of x, g of x comma y is nothing but x plus y, okay, so here the function is nothing but what, this g is nothing but plus, so we can say that it is nothing but what, it is nothing but expectation of x plus expectation of y, okay, it is always true. It, what is this, it means it is nothing but g of, इसका मतलब क्या हो रहा है कि इसका मतलब ये हो रहा है कि एक्सपेक्टेशन ऑफ g of x comma y is going to be equal to g of expectation of x comma expectation of y. It is following like this, okay, but in case of product it is not always the true, okay, so remember this is not always true for, I mean it is true for summation when the function is summation here, ठीक है, so okay, and one more thing is suppose you want to find ax plus b, since this b is a constant here, right, so you can always multiply, right, you know, just take a common, expectation of x plus b, it is kind of exception, you know, kind of exception you can say, याद रखना. So suppose we want to find the expectation of x into y, right, like product, expectation of the product, right, so if ये important है, if x and y are independent, if x and y are independent only when expectation of x times y, इसको पढ़ते कैसे हैं, expectation of expectation product of random variable x and y is equal to the product of expectation, product of the expectation of the random variable x, that is expectation of x times the expectation of y. But not always it is true, okay, remember it is only true, ये केवल कब correct है, when it is valid. See here the random variables are getting multiplied, the function is multiplication, okay, we are multiplying two random variables, and here we are multiplying individual expectation, right, the product of individual, you know, is equal to product of expectation of x and expectation of y, ठीक है, that is equal to only when x and y are independent event, right. You can also say that suppose expectation of g of x and h of y you are finding, right, like this function is nothing but a, this random variable is nothing but a function of a random variable, right, and if gx and h by are independent. In the question they will mention, or you have to prove it. Then this can also be written as expectation of g of x and expectation of h of y. ठीक है, ये प्लीज याद रखना. वैसे in general it is not true, but if there is a independence assumption, okay, if there is a independence assumptions, okay, then you can say that yeah, it is correct. ठीक है. So I think this is clear for all. Yeah, आप लोग ये नोट करें. एंड वेरिएंस, ये बहुत इंपॉर्टेंट है. इंडिपेंडेंस एंड वेरिएंसेस, हाउ इंडिपेंडेंस अफेक्ट वेरिएंस, हाउ इट सिंप्लीफाइज द लाइफ. ओके, so let me recall some of the like we have already computed, right? So if someone is going to ask you what is the variance of a times x, so it is always true what you have to take a square and then variance of x. Yeah, it is always true, right? Always you can say true. Okay, but suppose this is always true. If someone is going to ask you what is the variance of x plus a, it is going to be what? It is going to be variance of x only, right? Always true. Remember this. Okay, so if you are adding some constant to the random variable x or multiplying some constant, right? So this you can directly find out the the variance of ax or a variance of x plus y, right? That if you are multiplying with constant, so that constant is going to be coming out and a square हो जाएगा. जैसे मान लो तुम्हें निकालना है एग्जांपल के लिए what is variance of 3x, so this will be equal to 3 square variance of x, which is nothing but 9 variance of x. okay, इसको हम ऐसा भी डिनोट करते हैं, ठीक है, नोटेशन वाइज. बट सपोज देयर आर टू रैंडम वेरिएबल, मान लो दो रैंडम वेरिएबल को आप ऐड करते हो. इफ यू आर एडिंग टू रैंडम वेरिएबल एंड यू आर ट्राइंग टू फाइंड द वेरिएंस, सो एक्सपेक्टेशन के केस में फाइन एक्सपेक्टेशन ऑफ x प्लस बाई इज इक्वल टू सम ऑफ द एक्सपेक्टेशन, एक्सपेक्टेशन ऑफ x प्लस एक्सपेक्टेशन ऑफ बाई. बट इन केस ऑफ वेरिएंस, राइट, बी केयरफुल. Variance of x plus y is equal to variance of x plus variance of y. Okay, variance of x plus variance of y is not always equal, guys. It will be equal only when x and y are independent. So this is not true. Remember, always, not always equal, right? Please remember that. Okay. Variance of x plus y is nothing but variance of x plus variance of y. And remember, if x comma y are independent, therefore variance of x plus y is going to be written as the variance of x plus variance of y. It is only true when x and y are independent, right? It is only equal when x and y are independent. Please remember that. ठीक है? Okay. And in this case, you have to make assume that expectation of x, expectation of y is going to be 0. Therefore, expectation of x times y, okay, is, if they are independent, means expectation of x times the expectation of y is going to be 0 only, right? So this is our assumption as well. Okay. You can prove it. I need not to prove, but you have to make sure, right? So if they are independent, means if x and y are independent, means you have to make assumption also this expectation of the product must be 0. Then only variance x plus y is going to be the variance of x plus variance of y. Okay? I can prove it. See, let me prove. Suppose someone is going to ask you what is the variance of x plus y. From the definition, what do you say? X plus y, okay, x plus y, and you have to make assumption that, what assumption you have to make here is that the x plus y is the new random variable whose mean is 0. You have to make assumption this is very important, right? So just square it, that's it. Okay, if mean is 0, right, you have to make assumption. क्या assume करना है कि expectation of x is 0, it is given, expectation of y is also 0. So expectation of x plus y is also 0. Then only you can write like this. Now you can apply a plus b formula. तो ये हो जाएगा x square plus 2xy plus y square. Now you can apply the linearity property. So expectation of x square plus 2 times the expectation of x times y, expectation of y. Now if x and y are independent, मतलब ये क्या हो जाएगा, 0 हो जाएगा. And this is nothing but a variance of x plus variance of y, right? And it is only valid when mean, one minute, I think we have to minimize this. Yeah, okay, it is only valid when mean of random variable x and the random variable y is 0, expectation is 0. ठीक है. So I think this is clear, right? So here your assumption is very important. Why expectation of the product is 0? Because they are the mean, individual means are 0. So this is true when this is the fact, right? So suppose we are trying to find the variance of, example, let me take some example here. कुछ एग्जाम्पल ले लेते हैं. मान लो तुम्हें फाइंड करना है वेरिएंस ऑफ x प्लस वाई इफ x इक्वल टू वाई, तो क्या हो जाएगा, वेरिएंस ऑफ 2x, you can say that is 4 variance of x. Any problem? ये पहला आ गया आंसर. Second example we can take here is we have to find the variance of x plus y if x equal to minus y. Suppose two random variables are there which are opposite, so you can say that variance of 0, which is nothing but 0 only. And third one is if x and y are independent, if x and y are independent, they have to write this. If x and y are independent, right? So what is the variance of x minus 3y? If x and y are independent, they haven't furnished the information related to mean. So you have to consider that the mean of the random variable x is 0, the mean of the random variable y is 0. That is your assumption. That must be your assumption, right? As long as the random variables are independent. Okay, please remember these points. So variance x minus 3y is going to be the variance of x plus minus 3 square the variance of y. So variance of x, ये plus हो जाएगा, ये minus of, okay, so I think this is variance of y. तो मेरा कहने का मतलब है कि variance of x plus y is nothing but variance of x plus variance of y only when x and y are independent, right? And variance of x minus y is also variance of x plus minus 1 square variance of y, मतलब वही है variance of x plus variance of y, same argument. ठीक है, so I think this is clear. Yeah, yes. So we can now talk about the variance of the binomial distribution. Variance of the binomial random variable, right? So variance of binomial random variable means, suppose x is a binomial random variable, bin having the parameter n and p, n number of independent trials. Okay, so what is x here? The number of success, you can say, number of success. Okay, number of successes in an independent trials. Okay, so xi is going to be 1, xi is going to be 1 if ith trial is a success. Okay, if ith trial is a success, and xi is 0, you can say, because after all we are modeling this using Bernoulli. See, if we add many Bernoullis, okay, we will get the binomial, right? Okay, because Bernoulli means Bernoulli talks about success or failure only, right? But in case of binomial, there can be many success out of many trials. So if you can say that otherwise. Okay. These are the indicator random variable. Indicator random variable, and they are independent, sir. We can say they are independent. They are independent, yeah, because independent trials are there, right? If they are asking what is the variance of, so what is the random variable x, that is x1 plus x2 plus xn. So we can find now the variance. Variance is going to be variance of x1 plus x2 plus and so on plus xn. Okay. So now what we can do here is, there are n, like we can add individual variances considering they are independent to each other. Variance of xn, right? So variance of the Bernoulli random variable, right? What is the variance of Bernoulli random variable? That is nothing but simple, right? So random variable is like variance is going to be same for all, since there are n. Okay, so you have to multiply n, and you can say you have to just find the variance of this guy, right? That is variance of x1. What is variance of the Bernoulli random variable? That is p times 1 minus p. So इसका Bernoulli binomial का क्या होता है variance? This n times p times 1 minus p, right? So I think this is clear, guys. We will meet in the next session and we will take some problem as well, right? So thank you. Keep learning.